We have our custom layout all set, and we're ready to explore the video scopes. If you're following along with the lessons, you'll want to open up lesson 4 or whatever lesson we may be working on. And if you notice, with this layout, we can't see our project settings, but it's very easy. Just switch back to editing. You'll now be able to see your project panel. You can open the sequences bin if it's closed and simply select the lesson that I'm talking about. So in this case, I want to open up L4 Begin. You'll notice that any previous lessons might be open. To make things simple, just right-click and close other panels in the group, and now you have just the lesson that we're working on. And this is the strategy that you should use as you work in all the following lessons. Now let's switch back to our custom layout. Now we're ready to explore how to use scopes. But let's back up a little bit. Why use scopes? Well, it's simple. Scopes are a mathematical way of looking at your image. They will always read the image the same way as opposed to your eye, because if your monitor is brighter or darker than it should be, and you color correct or grade based upon your monitor, your show may end up too bright or too dark. And the same thing's true about color. Maybe your television has a little bit of a red tint to it. So to compensate, you're going to add a lot of blue, but then your final show really won't be properly color corrected. It'll be corrected just for your TV set or your monitor. You want to make sure everything is neutral, and that is what video scopes are all about, because it looks at the signal that's coming in, and as you modify it, the scopes will adjust. Let's take a look at how to use the 4 scopes that we'll be leveraging during the rest of the course. The first scope I want to talk about is the waveform monitor, which we see in the lower left-hand corner of the screen. Let's make this the only scope we're looking at. So right-click in the Lumetri Scopes panel, go to Presets, and choose Waveform RGB. You'll notice that the Waveform RGB shows all these colors, and that's nice in some instances, but we really want to focus just on brightness and darkness levels. And to do that, it's good to work with the waveform as just Luma versus RGB. So go ahead, right-click, select Waveform, and choose Luma. And as we see, it's black and white, and we're not distracted by all those colors, and we can really focus on the brightness or the darkness of an image. And the best way to explore brightness and darkness is to look at something that is gray. So let's move to the next clip, and you'll see that if this is pure gray, it's right there at 50%, and if you're used to looking at things on a scale of 0 to 255, it's right there at 128. Now what happens if we brighten the image? Well, let's go over to the exposure slider in our Lumetri color panel, and as we brighten the image up, you'll notice it turns white and that slider goes all the way to almost 100. If we move the slider control of exposure all the way to the left, the image gets darker till it's practically black, and you'll notice that it's running at around 5. Now this is interesting. First of all, when you're dealing with luminance, you want to keep everything between 0 and 100. Anything over 100, you'll lose detail in the highlights. And if it gets too dark, you can lose the details in your blacks. The term is your blacks are crushed. Now, if you've been playing with these sliders, you might also notice that really you can only get to 95 and down to 5, and you're wondering, why don't I have full latitude in my controls? This is an intentional design by the engineers at Adobe, because the Lumetri color panel is designed for you to very quickly create beautiful images without hurting yourself. So they've limited the range of control so you don't blow things out and you don't make things too dark. Doesn't mean you can't do it within the application. There are plenty of effects in the effects panel that you can choose that will allow you to really stretch or shrink the dynamic range of an image. Don't panic, because it's intentional that all of the sliders in the Lumetri Color Effects panel protect you from creating a truly ugly, non-broadcast safe image. So how do you read a waveform when you're actually looking at an image? Well, let's dive into the next image here, pun intended, and you can see the brightness levels across the image. And I specifically use the term across because this waveform scope actually reflects the image from left to right. You'll notice I have a really bright light here, and if I look over at my waveform, I see it spiking in the same location. If I look over at the right side into this area here, there's a lot of dark pixels, and I look over here and I can see the same dark pixels. So it's very easy using the waveform scope to see what parts of your image may be too bright or too dark. Now let's work with the sliders and modify this. Now we're going to go over to the basic correction section of the Lumetri color panel and simply grab the same exposure slider, and if I move it to the right, the image gets brighter to the point where you're actually losing a lot of the punch. But look at the scope, it's moving up, and what I'm doing is moving all the pixels into a brighter place. And when I move it to the left, it takes all the pixels and pulls down their luminance. As you can see, the waveform scope reflects any changes you may make in the exposure of an image, as well as you can see there's other tools, contrast and highlights, and we'll look at those in great detail in a later lesson. Now let's look at some more scopes that you'll be using. The next scope that we want to use is the vector scope. So go over to the Lumetri Scopes panel and simply go to the preset of vector, and you want to choose YUV. Now I'm going to make this full screen by hitting the tilde key and explain what we're actually seeing. And it's best to do this by looking at some color bars, which is the next clip in your timeline. You'll notice that there are these little boxes, and those are targets. And the white area, these are called traces. And if you look at bars, all the bars are the exact proper saturation and luminance values to fit into these little squares. And the thing you want to keep in mind is you don't want your traces to exceed the location of where those little target boxes are. Let's switch back to our regular screen and look at how adjusting some of our color sliders affects the image as well as the vector scope. Using the same diving shot we saw before, you can see that nothing exceeds any of our targets, and it also reflects different colors within the image. So for instance, there's a lot of cyan over in the left side of this image, and if you look at our vector scope, you see a clump of colors that are pointing in that direction. There's also a lot of blue, and that's reflected over here. There's a little bit of red, and there we go towards the red target. Now let's move some sliders and see how it affects the image and the scope. The first thing I'm going to do is simply grab the saturation slider, move it to the left, and you'll notice that as the image moves towards a more desaturated state, or black and white, that the vector scope shows a single point, which means no color. So as I increase saturation, all of my traces will go further and further out to the edges of the circle. And if I increase my saturation too much, I'm going to do two things. One, get a really ugly image, and two, exceed broadcast safe levels for saturation. So pay attention to those little targets because you want to remain inside that area to make sure that your color is safe. Let's go ahead and double click on this, and this will return us back to our original state. And I want to show you what happens when we play with these sliders for temperature. If I add more blue to the shot, do you notice how the vector scope is moving towards the blue and cyan area? And if I warm it up, it's moving towards the red and orange area. The same thing is true if I start adding both green and magenta. So for a neutral image, you want to see the bulk of your information towards the center. And of course, if you have specific colors, you're going to naturally see spikes in that part of your vector scope. Moving forward, let's explore how the RGB parade can further help you understand what's going on with color in your image. Back in the Lumetri Scopes panel, right-click, go to Presets, and choose Parade RGB. And to really see what's happening in the RGB scope, I'm going to jump to the specific colors. Now these are pure red, blue, green, white, black, and gray. As you see, since this is pure red, it's reflected in the RGB parade. It's 100% red and there is no green or blue colors in this shot. Now I'm going to jump back for a moment just to the dive shot, because here we have a mix of red, green, and blue. So if you have a normal shot, you will see that you'll have a lot of information throughout. Let's go to look at the blue. Just like the red image, all we have is 100% blue, and the red and the green are at the bottom. Same thing with green. Now what happens when we go to an image that is pure white? Well, pure white in an RGB color space is made up of 100% red, 100% green, and 100% blue. So what would happen if your image is completely black? Well, it's pretty easy to guess that you're going to have 0 for red, green, and blue. And if you're at a nice 50% gray, again, red, green, and blue are all equal. And this is important to note because when all of these traces are equal, your image is going to be neutral without any color cast. And finally, let's look at color bars. And as you can see, there's a lot of different tonal ranges and variations. There's solid red, there's mixes of red and blue, and all of these are reflected in our RGB parade scope. Next, we're going to look at the histogram scope. So I'm going to simply switch to my hand tool, slide over so we can easily move to the next clip, which is our dive clip. And we're going to switch our scope from the RGB parade to a preset of the histogram. Now, what the histogram is showing us is the number of dark and light pixels across our image. Now here it's broken up into all the different color ranges, but more important, what do we use the histogram for? And I use it to see the contrast of an image and also a little bit the luminance or the brightness as well as the darkness or the shadows. So looking at this image and going back to our sliders, what happens if we increase the contrast of the image? Well, you'll notice that the histogram spreads out. And if we reduce the contrast by moving our contrast slider to the left, you'll notice there are less truly bright areas, which are reflected on the top of the image, and fewer truly dark areas, which is reflected by the bottom of the image. I'll do a quick slide back and forth, and you can see how the histogram reflects the contrast of my image. It also reflects the exposure of my image. Let me go ahead and reset contrast. If I make the image brighter, you'll notice that the histogram has a lot more white pixels and it moves towards the top. And if I move it to the left, as it gets darker, the histogram reflects most of the pixels are black, kind of black, and sort of black. So once we start color correcting, you'll be able to use the histogram to really see if the contrast is right and you're using the full dynamic range of the image that you're working on. So there you have it, a better understanding how to read your primary four scopes, waveform, vector, RGB parade, and histogram that will reflect the true luminance and color in your image. Because remember, it's easy to fool your eyes when looking at the picture, but you can't fool a scope.